Yeah, hi all. Today topic is first what is Linux kernel and Linux device driver architecture and Linux architecture and how to communicating to user space to kernel space. This is the today topic and here it's a topics. It's like Linux architecture, Linux device driver architecture, how to communicating to user space to kernel space. In first it's Linux architecture. In this here it's a main uh, components or our main topics are its hardware and kernel shell and utilities and application. These are the Linux architecture blocks. This is the just it's a hardware, it's a and kernel shell application and utilities. Yeah, we see the one by one. First it's a hardware. The innermost layer represent the hardware, which include all physical components of the computer such as CPU, memories, storage devices and physical devices, and this layer interact directly with kernel. Means here first application layer, kernel and hardware, means this layer interact with directly kernel. And next it's a kernel. The kernel is the core of the operating system. It is responsible for managing the hardware resources and providing an interface from system process and applications. So this is the middle layer of Linux kernel or Linux architecture and device drivers also. It is the Linux operating system, core of the Linux operating system. It's including some handlers such as process management, creating and scheduling and intermitting the process, and device management, allocation and deallocation of the memory of device driver and particular module, or all those things. They allocating to the memory and deallocating the memory in memory management, device management, interacting with hardware devices through device drivers, and also file system management, managing the file operations and storages, and networking management, handling the networking operations and protocols. All these process management, memory management, device management, file system management and network management, all these are in part of the kernel. And next, shell. The shell is an interface between the user and kernel, and it allows the user to execute commands and scripts to perform various tasks like bash script or jet script and some scripts whatever you are providing in command line interface, that in to execution purpose we are using the shell here. And next, utilities are basic programs that provide essential functionality to manage the system. They include commands are ls, cp, move, rmps, staff. If config means it's a network side. File manipulation side, copy, move, remove, and we see the ls. These are that. And system monitoring purpose, bs, ps, stop, df, networking, if config, ping, and user management side, user add, password, all those things. These are the utilities in Linux architecture. And next, it's applications are programs that run top of the shell and provide the specific functionality of the user. Means it's based on that application we are changing that behavior, all those things. These are the uh, Linux architecture blocks: hardware, kernel, shell, applications and utilities. And this is the just a diagram representation how to it's means. First it's a hardware, it's a layer, it's a core, and a kernel layer surrounding the hardware managers resource, and this thing just diagrammatical explanation, that's it, nothing is else. And next, Linux device driver architecture, in that mainly user space, kernel space and abstracts layer. Here it's a first, it's a Linux kernel device driver architecture. First it's a application layer it's contain the C libraries and all those things, and as a user applications are running in application layer. And in kernel layer it's a main core in kernel, that is system interfaces, general services, device drivers. All the components or all the functionalities are in kernel space, and kernel Linux kernel only it's a present. And then it's a hardware is the interacting with the kernel, and kernel it's interacting with the user space. It's like it's a flow. And if you take it's a like it's a take kernel space, the the core part of the operating system where the devices driver resistant, and the device drivers operate within the kernel space and directly interact with the hardware. It's an interaction with the hardware, kernel space, and user space application running the user space communication with device drivers through system calls and APIs. It's communicating to the kernel space. Means it's a user space, user communicating to the kernel communicating to the user. It's a middle layer. It's kernel space, and just it's abstraction layer. It's optional. Linux provide the abstraction layer, simplified the interaction with hardware. System call interface, so connect the user application to kernel, allow to system calls like open, read, write, and device specific driver code, managing the hardware specifications. Kernel subsystem, it's a networking, USB, all the general driver functionalities are present in Linux kernel subsystem. And next, key component in Linux device driver architectures. What are the key components? Means here first it's a device files located in the dev directory, slash dev directory is represent the physical or virtual devices are providing the standard interface for user space interaction. This is the device files. And next it's a major number and minor number. Major number identify the driver associated with the device, and minor number identify the specific device handled by the driver. Means it's a same major number, it's a multiple drivers is contained, but it's a unique one, it's minor number. To identify that and the particular driver and our device by using user number and minor number, we can identify that. And next it's a kernel modules. It's a device drivers or often implement the kernel modules that can be dynamically loaded and unloaded. It's like means it's if you want to load means it's using INS mode and mode probe, or removing means RM mode, and list means what are the modes contain means we can see the LS mode. These are the some commands. It's kernel modes in uh, loading and unloading, and just removing the and listing what are the modes contain or the modules are contains like. Next, device tree user use it for describe the hardware in embedded system means, and provide the information about hardware devices and kernel at boot time. It means it's a main it's a device tree. It's a contain the all hardware information. It's a whatever you're using. If you take it's a camera driver, in that it's a all information about related to the camera, and what is the vendor you're using, compatibilities, and what register you are using, which protocol you are using, all those things. It's a contain the uh, in a device tree. And next it's a device driver framework and subsystem. Virtual file system, abstract file system operation. TTY means it's a like handle the terminal IOs, and this is a protocols. It's a like I2CSP USB subsystems, the standard access to hardware protocols and buses. These are the one. And next, typical workflow of the device driver. How to it's a workflow it's happen in a device driver. First, initialization. First, register the driver with kernel using register dev. First it's a register dev, using register dev and similar method, and create the device file and allocate the major and minor number. First, initialization, register the driver with kernel user register dev, and then it's a create the device file, allocate the major and minor number. And next, interaction, use interface function pointer for open, read, write, IOCTL calls, and define user space also, user space interacting with the driver. And hardware communication, write and read from hardware register using memory mapping, IOs and ports, cleaning and register the driver and release the resources during the driver removal. So means is the initialization, interaction, hardware communication and cleanup. This is the main driver flow concept, and need to implement the driver with this is the main components. And user space interaction, for users, how to user interacting with user by using system calls, application user system calls like open, read, write, interact with the driver. And otherwise it's IOCTLs provide the interface for custom commands not covered by standard system calls. It means it's a custom, by using custom command we can communicating to the user and kernel space. And libraries, firmware like libusb for USB drivers enable the simplified accesses. These the user interactions of by using system calls or IOCTLs, and for libraries we can communicating to the user and kernel. And next, typical workflow of device driver, it's already done, sorry. Okay, next, how to communicate user space to kernel space. Here it's these 3 points, it's a 4 points to communicating to the user space and kernel space. First, application request, software interrupt and kernel execution and return to the user space. Just here, first application request. The user application make a request for the kernel service such as file IOs, memory allocation and hardware interaction. This is a typically done user system calls, read, write, IOCTLs, and system calls serve for the interface between the user space and kernel space, ensuring the control access to the kernel resources. For example, if you want to interfd open application request to the kernel interaction, it's a particular device, a device file we are interacting with the kernel space side, and read or write or something. And next, software interrupt, when the application issues the system call, the software interrupt is generated. This transmitted to execution context for the users to kernel space. The interrupt inform to the kernel that request for the privileged operations has been made. Key mechanisms. The processor switches to the higher privilege level like ring x86 architecture. The interrupt vector table is used to locate the appropriate kernel functions to the handle the request. And next, it's a kernel execution. The kernel processes the request to the protected environment. This involving to validate input parameters, performing the request operations, reading from the file and interacting with the hardware, and update the kernel data structures if necessary. Means this the whatever it's involving, it's a request, it's a we do it. Means for example, in case of the device communication, the kernel might be interact with the device driver to handle the request and return to the user space. Once the kernel complete the operation, it's prepare to the result and return value, or if you get error, it's a get the error code. The control return to the application in user space. This involving restoring the user space context and resume the application execution. If x is either disable successful or not, we can checking to the every time device successfully or not. And this is the user space and kernel space transmitted the occur through the system calls triggering the software flow, or kernel execution, kernel handling the requesting using to the interaction mechanisms and device driver, and kernel space to user space, result is written to and control resumes to the user space. This is the simple flow. This is the basic structure of uh, character driver. What are the functional, for me mainly they are asking what are the APIs involved, or what are the functions are uh, involving to writing device driver, character device driver. It's a main, it's a when that's open system calls, it's a, these all are the application open. It's just one static function, and this is the file operation structure, and one more is init function and also exist function. These are the main, it's a file operations, and init and exit, these are the main functions, and in to implement any driver. And how to do system calls workflow. First, it's a user, it's application requests a system call software. This is the just a diagrammatical way. Just I'll take some example, one example. And application request to the system call software interrupt switches to context to the kernel mode, and here in kernel side it's a coming system call identify, and kernel functions based on system call it's executed, and then system call return values to the prepared, and execution context return to the user space. This is the application resume to the execution. This is the just a flow to how to user and kernel it's an interaction. This is the flow, means it's a system call request, context switch to kernel space, and system call identified, and kernel function execution, system prepared to return value, and context switch to user space, and it resume the application. So first, okay, this is the system call request, the application requesting to the system call invoked. For example, I'll take high level overview explanation of system calls work. It's a system call requesting, the application request to the system call and involving the corresponding function, and its instant program might be use the read function and read data from the file. And context switch kernel space, it's a software interact with a special instruction is used to trigger the context switch and transmission from the users mode to kernel mode. And system call identify, the system call uses to the index of the identify the system call and address to corresponding kernel functions. Then it's a kernel function, it's a kernel function, it's a corresponding system call executed for the reading the data from the file. And system prepared to the return, it's like after kernel function completed, it's a operation and return values returned to the prepared to the user application. It's a context switch, it's a switch back to the kernel mode to user mode. It's a resume the application resume it execution from the where the left off, now which the result are affecting to the work, affecting the system call. This is the workflow for user space to kernel space. It's a requesting to the application for user side, and switch software interrupt switches context to the kernel mode, and then in kernel side we are trigger the system call identification, and then execute the execution based on kernel function call. It's a means your system call, it's a read or write or something, and this way reading the data or writing the data or kind of thing. So based on functionality it's executing, and system call return value, after that some execution is completed, then system call return values are prepared to the back to the application side, execute the context return to the user space. This is the flow of users to kernel case communication. uh, these the all the topics, just here it's a Linux architecture, how what is the Linux components in blocks are involving the Linux architecture. It's like it's a hardware, kernel, shell, utilities. These are the, this is the specific to the Linux architecture, and Linux architecture is slightly different, and device driver architecture is slightly different, it's not both are same. So it's a here it's a majorly user space, kernel space, and inside the kernel space is a system interfaces and generic services, device drivers, and this a kernel is interacting with the hardware. But in here it's a different, it's a like it's a hardware, kernel, shell, and application. This is the like it's a software side, it's a like it's a made kind of the Linux architecture, and that is the Linux device driver architecture. And here it's a workflow of device driver, how to it's a workflow interacting with. First we register the kernel driver and create the device file of a particular driver, and allocating the major number and minor number, interact by using interacting to the open functions. It's a read and write and all those things we can use, and interacting with the users to kernel space. After that all the things is done, just it's under register the driver and remove the driver, all those things it's a come to the picture. Yeah, this is the workflow of just user space to kernel space communication. How do that happen? And this is the basic. What are the structures in involving character driver? This is the open. It's a one function is there, and stuck. It's a file operation structure is the one, and next it's a init function and exit function of initializing the driver and uninitialize mirror or unload. For that we are using the existing exit. This way we are interacting. This is the flow. uh, yeah, thank you for watching. Can you please like, share and subscribe that channel? Thank you for watching. Thank you.